All right, this is another classic question. Valid parentheses. Given a string S containing just the characters, these parentheses determine if the input string is valid. And it is valid if it satisfies these two conditions. The open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. So let's put this in perspective. What does it mean? So if we have an input string S, so you have a pair of parentheses followed by square brackets, and then you have curly braces, right? So that means this is valid. But if we have a opening parenthesis, but we have a closing square bracket, and it's not closed by the closing parenthesis, that means it's not valid, right? So another example would be you could have for example, you have a parenthesis, but embedded you have a square brackets, and then you have for example, a pair of curly braces inside. So that's another valid parenthesis. Or you could have the curly braces outside. So something like this will also be. So it has to be the same parenthesis has to be closed by the same type of parenthesis, right? All right, so let's look at how we tackle this problem. We may find a pattern here. So if we, for example, every time we encounter an opening parenthesis, right? So we're gonna use a stack. We're gonna just use a stack to put in its corresponding closing parentheses. What did I mean by that, right? So let's go one by one. So we have an opening parenthesis, and then in the stack we're gonna put a closing parenthesis, right? So we have a closing square bracket. We're gonna say put its counterpart here, right? So and then but if we have a closing parenthesis or closing square brackets, we're gonna keep it the same in the stack, right? So and then every time we have a closing brackets, that means if it's not a opening parenthesis, we're gonna pop that from the stack, right? So let's just complete this first. So if it's the next one, it will be a closing parenthesis. The next one is a opening curly braces. So we're gonna put a closing curly braces, and then last one here. So first, right? So first we put a closing parenthesis, and then a closing square brackets, and then the next one is a closing brackets. Then we're gonna pop this one, take what's on the top of the stack. If it's the same, then we're gonna pop, right? So after we pop, then we are left with a closing parenthesis. Then the next character will be exactly also a closing parenthesis. So we're gonna pop that as well. Then the stack will be empty. And then last but not least, we have a curly braces. So and then we're gonna put in the stack a closing curly braces because this is opening one. And then lastly, we have a closing curly braces. Then we're gonna pop. Then eventually, if it's valid, the stack is going to be empty. So let's look at a non-valid example. If I put this closing brackets into here, right? So what's gonna happen is so first you have a closing parenthesis, and next you keep this as a closing square bracket. The next, because it's a opening square bracket, so we're not gonna pop from the stack. So eventually we're gonna have another one on the stack, right? And then next we have a closing parenthesis, and then we're gonna have to pop that, right? But then we found out that if we pop the very top elements from the stack is not equal to the corresponding closing parenthesis. That means it's not a valid parenthesis string. So it sounds a little bit confusing, but let's put it in perspective by code, right? All right, so like we said, first we're gonna define a stack of characters. All right, we're just gonna call this stack. All right, is equal to new stack. Apparently we have to do a loop, right? So for each character, let's call it C in this string. So we're gonna say to_char string. That's gonna convert the string into a character array. If C is equal to remember, notice I'm using a single quotation for character. If it's a opening parenthesis, I'm going to stack dot push a closing parenthesis, right? So closing parenthesis, semicolon. Sorry, here should be opening parenthesis, and then else if I can probably copy this over. So else if it's equal to a opening square bracket, I'm going to push a closing square bracket, right? So likewise, opening curly braces, curly brace, and then closing curly brace. There we go. And last but definitely not least, this is the default case. If we reach the end of the stack, so if stack, oh actually let's say if stack is not empty, if the stack is not empty, or if stack dot pop, so if it's not any of these, so if it's a valid parenthesis, it could be any of the closing counterparts, right? So if it's any of the closing counterpart, we're gonna pop the top element from the stack, right? So and say if it equals C or not. And if it's not equal to C, and remember this one is going to return the element from the top of the stack, but in the meantime it's going to remove the element. So we don't have to we can just put this within the if statement, the condition part. So if that's the case, if the top of the stack is not equal to the current character, and by the time we reach here, because we already passed these conditions, that means this character has to be one of these closing cases, right? Otherwise it will fall into any of these categories. So if the top of the stack is not equal to the character, that means it's not a valid parenthesis. Or if we reach the end of the stack, but the stack is not empty, remember, in order for it to be valid, at the end of the process, the stack has to be empty. If it's not empty, that means it's not valid. So if any of these conditions are true, so we're going to return false, right? And otherwise, we're going to return true. So that means we loop through everything and the stack becomes empty. And for every step of the way, the top of the stack is equal to the corresponding closing case, right? So let's run this algorithm. Stack.pop. Let's see. Oh, we have to put additional parentheses here to wrap this around, so that it's not confusing if it's not equal to the character. Okay, I think I was missing the closing parentheses for the last if statement. And let's submit the algorithm again. Okay. Alright, so here I could say is not equal to the character, right? So and then here we shouldn't be not empty but empty. So why that's the case? So just think about, once we reach this point, that means we're still in the character array. So if we're still in the character array but the stack is already empty, that means we have parentheses that cannot be matched because the stack is already empty and it's unbalanced. It's not even an even number of characters in the array. So an example will be, so we have two opening square brackets, but we only have one closing square bracket, right? So that will break the balance. So because the stack is going to be, so we have a close, close, and the next one will be close, and then that means we're gonna pop the previous one, and then eventually this is the end of the stack, right? So if it's the end of stack and if it's still not empty, that means it's not going to be a valid parenthesis. And last but not least, we're not going to return true. So we're going to return if the stack is empty or not, right? So let's see, let's submit the program. There we go, right? So hopefully this makes sense. And this is another classic example of using a stack to detect every time you have problems like this. You have a pair of characters or things like that, you want to see if it's a balance or not, you can apply the same logic.